begin with, we're going to do a little review. And I'm going to call on some of you guys to help out, okay? So be ready for that. We're going to review what we learned yesterday about genes and genetics and how they're organized in our cells. After that review, we still need to continue on because we didn't finish that yesterday. So we're going to continue learning about how our genes are organized. Remember, we're talking about genes with the G, not a J, right? We're talking about our genes in our cells, not your pants. Okay. So we're going to use the textbook to help us do that. And we're going to use a video to help us do that as well. It's a little short video. And then notice, you get to take a short, sweet quiz. It's only a half page long. That's it. It has 6 questions on there. But what you're going to do is prove what you learned about the organization of genes. So prove what you learned yesterday and today. Okay? All right. After that quiz, then we're going to switch gears. We're going to head to God's Word and see what does God have to say about your DNA and how He knits you together just like He wanted you. Okay? Go ahead to God's Word for that. All right, so go ahead and get those supplies out. In fact, open up your notes to yesterday's work on organization of genes. All right, so review your notes while my screen's coming up, okay? Review the organization, where you find your genes, where you find your chromosomes, what builds up what. Because I could be calling on you to help us review. All right. On the screen, you should see an illustration. This is an illustration of what we learned in this class yesterday. So, who was listening well, has reviewed their notes well, and you just feel confident that you could come up here and you could show us exactly what's going on and what this whole illustration is even about? Who has the confidence that you could do that? Come up here and review it with us. All right. I see that hand, Owen. Why don't you come on up and go ahead and share what you see on the screen. Help us review, please.
Well, this is a guy, and and he has this is one of his skin cells. And inside the nucleus, he has chromosomes, which are little packets of information.
Okay.
And then the chromosomes are made of DNA, and then a gene is a specific section of the DNA that tells a characteristic about you. Like if you have blonde hair, then there's a gene that says you have blonde hair.
Okay. Now, to me, DNA and the gene picture look a lot alike. Are they the exact same thing, or are they different?
Yes. They're the same thing, but a gene is a little section of DNA.
Oh, so a gene is a section of your DNA. All right. Excellent job. Let's give him a hand. There you go. Thanks, Owen. You gave us a great review of what we learned in class yesterday, didn't you? So this illustration takes you from a human level or a living organism all the way down to the gene, the instruction guide, the blueprint that makes that organism exactly who or what it is. So in this case, it's a human, right? Could we do the same thing with a plant? Could we look at a plant's cell?
Yes.
In that plant cell, would there be a nucleus?
Yes.
Would there be chromosomes in its nucleus?
Yes.
Would there be DNA in the chromosomes of the plant cell's nucleus?
Yes.
Do plant cells have genes?
Yes.
Absolutely, but very different than our genes, right? Okay. How about this? How about a one-celled bacterium? A bacterium. Could we look at the cell of a bacterium?
Yes.
Pay attention, trick question. Could we look inside the nucleus?
No, not in the nucleus.
They're prokaryotic.
Ah, I couldn't trick you guys, could I? All right, bacteria cells are prokaryotic, so that means they don't have a nucleus, but they do have genetic information in here, don't they? They do have chromosomes, and if you look at it, it would have DNA, and then that has genes. So really, any living organism could fit here, couldn't it? All right, so we learned how to organize that yesterday. But you know what? We have more work to do. We didn't finish. Can you guys handle more?
Yes.
Sometimes.
Yes.
Possibly.
All right, so in your notes, what we're going to do is we're going to continue on in your notes with the help of our textbook. And you're going to get to learn some more parts and pieces that build up your genetic information. So let me show you another illustration, okay? Another illustration for you. It's a little pyramid. Remember on our tests, I like to put pyramids on our tests, don't I? I like to put little organizational charts. I'm kind of a visual learner. If I see it, it helps me remember it. And I know some people can just listen and get it, or just read and get it, but I really like to have visuals. So I hope this is helpful to you. If you're a visual learner, you probably appreciate it. And maybe you're not a visual learner, but maybe it can help you, okay? So here's another visual for you. A pyramid, not from ancient Egypt, but an organizational pyramid. Now in this organizational pyramid, we have the parts and pieces of your heredity, or your genes, or your genetic information. At the bottom, that would be the biggest, wouldn't it? So the largest thing in our pyramid would be your chromosomes. You know, those look like a giant X, don't they? Inside your nucleus. But then chromosomes are made of smaller parts and pieces. They're made of DNA, right? That's a real long double helix ladder. Here's something really cool about DNA. If we were to take your DNA and just one of your cells, Sully, just one, and we stretch that double helix ladder out, it's going to be about 6 feet long. That's taller than me. So your DNA, if we stretch it out, would be about 6 feet long. Just out of one cell. Imagine if we got all the DNA out of every single cell in your body. We could actually go around the solar system with just your DNA in all your cells.
Wait, what?
How far can we go with every single
You
person
trying
in
to
the
make
world?
my brain hurt so.
Wow, that like
One person can go towards
brain
the
explosion, right?
Nah.
All right,
I would confuse
so
me.
DNA build up and make your chromosomes, right? But DNA, and this is where we left off yesterday, DNA is even made of smaller parts and pieces. Oh my, we're getting incredibly tiny, aren't we? In fact, we're getting so tiny that you can't use a microscope to see these things. You would have to use an electron microscope to see these things. And we don't have enough money to buy one of those, sorry. In fact, a lot of colleges and universities don't have enough money to buy one of those. So it's a very rare type of microscope. But DNA is made of these things called proteins. Now there's another fancy word, we could call them nucleotides, and a lot of times in science we give everything multiple names. There must be some scientist sitting somewhere that just enjoys naming everything, right? Especially with fancy names. I like to call them proteins. That seems more simple than nucleotides, right? Your DNA is made of proteins. But you know what? You've probably heard the term proteins before. Did anyone eat any protein for breakfast or for lunch?
For lunch. Nope.
Huh. Did you eat some protein?
I think so.
Miss Oak, what did you eat?
I know peanut butter has protein, but I said peanut butter.
Yes, peanut butter has protein in it. Any kind of meat would also have protein in it. So if you ate like bacon for breakfast, or if you ate like a bologna sandwich or something.
For breakfast.
Does anyone eat bologna anymore?
No, it's nasty.
I mean,
It's nasty.
I like it. It's good. If you fry it, ooh, it's good.
Oh yeah, my dad said it's good if you fry it.
Fried bologna. But meat and nuts and things like that have protein. Now notice it's in the food that you eat. Now here's the cool thing. You eat that food, your gut pulls that protein out and then uses that protein to build and make new DNA for you and all the new cells that your body's making. Because your body's making new cells all the time. Like your skin's sloughing off right now. And you have to make brand new cells to replace it, right? That's amazing. And to think God just designed all this, right? To keep us living and functioning. All right. But even proteins are built up and made of even smaller pieces. Amino acids. And we're going to discover what all this is today. All right, y'all ready for this?
Yes.
All right, then let's do this. Let's head to our notebook. We're already there. Let's head to our textbook. We're not there. Let's also open up to page 102. Let's discover what in the world is DNA. Deoxyribonucleic acid. Let's find out what that's all about.
What page? What?
Page 102, please. Comes after 101. So it's the page right after the Dalmatians. 101 Dalmatians. You got it, didn't you? All right, so page 102. You have a title here. It says DNA is coded messages. Whoa. We're going to discover exactly what DNA is inside your cells. It's pretty amazing. All right, so who would like to read and share? The first little paragraph under DNA is coded messages. All right. Mr. Nelson, would you do that for us? I do that a lot. I'll look at someone and then call someone else's name. It's kind of fun to do. Because then the person I looked at is like,
Like, why is that fun? It just ruins their day.
Yeah.
oh,
It makes the other
Andrew's laughing now.
very happy.
All right. So, Mr. Nelson, you got it?
Yes, sir.
All right. So everyone pay attention as he reads on page 102. Here we go.
In 1953, after many years of research by many different people, James D. Watson and Francis H. C. Crick worked out a model for the structure of a deoxyribonucleic acid, or DNA.
Whoa.
What?
I'm sorry. You did amazing. You pronounced that just right. I'm amazed. That big word is a big word for DNA. Deoxyribonucleic acid. Let's all say it. Deoxyribonucleic acid. Deoxyribonucleic acid. Deoxyribonucleic acid. Deoxyribonucleic acid.
Say it 5 times fast.
I can't even say it once.
Some of you guys are like, nah.
Deoxy.
All right, so deoxyribonucleic acid. That's the big fancy word for DNA. Mr. Nelson, you did incredible. You pronounced it just right.
There was a thing after it that said I pronounced.
Oh, you used the cheating? Yeah, you used the pronunciation kit. All right, so why don't you go ahead and finish up that chapter. Sorry I had to interrupt you. But you just did so phenomenal. I had to say something. All right, go ahead.
The model they proposed looks something like a twisted ladder called a double helix. This twisted ladder is made up of units called nucleotides. There are 4 different kinds of nucleotides in DNA. Each contains a sugar, a phosphate, and a base. The sugar and phosphate are the same in each nucleotide, but each nucleotide can have 1 of 4 different bases. The 4 bases are these: adenine, thymine, cytosine, and guanine.
Tell you what, you were brave. You were brave tackling that paragraph. It had a lot of big words, didn't it? All right, so we're going to get to those words. And first, let's do this. First, let's define deoxyribonucleic acid, also known as DNA. DNA. All right, here we go. So, DNA, or deoxyribonucleic acid, is the blueprints. The blueprints of life inside your cells. Also inside plant cells, or bacteria cells, or little amoeba, fungi, all cells. So DNA, the blueprints of life found in your chromosomes. But Tyler would have been told us those are made of parts and pieces, aren't they? DNA is made of 4 key proteins. 4 key proteins build up and make this DNA strand. And you can see a DNA strand looks a lot like a ladder that's twisted, doesn't it? Okay, so let's make sure this is in our notes. You will definitely want this in there because it will help you on our upcoming quiz. And
He's gonna say something else after that. So
Yeah,
I was like,
we don't need to like draw the picture of the bottom.
you don't have to, but you may. You want to add in a DNA strand. All right, so we keep getting smaller and smaller and smaller, don't we? And we went from a cell to a chromosome, now to DNA. So DNA build up and make your chromosomes. But even within this definition, DNA is made of proteins, right? 4 different proteins. Yes, Andrew?
Does RNA have anything to do with DNA?
Yes, it does.
wow.
Unfortunately, we don't have time to worry about that today. But we will on Thursday.
Okay.
Yep, DNA and RNA are a lot alike. They're almost like twinsies. So we'll discover why on Thursday, okay? Good future question. All right. So does everyone have their definition of DNA? Okay, what I'm going to do here next is bring up another illustration for you that kind of shows you where we're going and where we've gone. So you know that we've gone from inside the cell to the chromosome inside the nucleus to the DNA strand, right? The DNA strand has parts and pieces that Owen told us about, right? A section of DNA is called a gene, isn't it? A section.
Yeah.
Now we've been introduced to a new part. Nucleotides or proteins. They go by the same name, okay? Nucleotides and proteins. In fact, why don't you draw this quick little illustration in your notebook?
Okay.
Yep. Another illustration. This is like art and science. It's awesome.
It is.
Pull out the colored pencils and paint.
Is our quiz on this?
Wait, you can't plug pencils? Okay.
Oh, good point, Jill. Our quiz is about this information, so yeah, thanks for reminding us. We'll make sure that's in our notes, and Dylan.
This is Michelle's secretary. She gives us a quiz over the problems we do in class to make us take notes. You're all supposed to.
That's good.
I know.
Who? Miss Patel's. Oh yeah.
Now, what did I say was another word for nucleotides?
Proteins.
Proteins, yes. And in fact, in your illustration, you might want to put both words, okay? So nucleotides and proteins are the same thing. And I'm sorry, we get awful naming in science, and we try to give everything multiple names sometimes. But I want you to at least be aware of both names in case you run across them again in other reading or literature. Now then, let's do this. Let's go back to the textbook and let's discover nucleotides and proteins. In fact, go ahead and flip back one page. Go to page 101, the page of the Dalmatians.
Wow.
Every time I hear 101, I think of Dalmatians.
Oh my gosh.
Just make the connection.
Yeah.
Look, there's a question about RNA on here.
What?
I think there's
RNA?
types of symbiosis.
On the pink box.
Oh, you might. You're trying to answer your own future question, aren't you? All right. So on page 101, it introduces us to nucleotides and proteins. All right, check this out. It says here at the bottom of page 101, under how genes function, it says, suppose you were given the job of sending a message, a top secret message, encrypted and encoded. Maybe you send it like, a note in class. You guys don't do that, do you?
What?
Where do you send
Whoa.
messages to each other?
On your phone.
Your phones?
My
Okay.
brain.
Telepathically?
Telepathically.
Whoa.
Me too.
Teach me your ways. No. So suppose you were given the job of giving a message, relaying a message. Okay. Now it says, but you have to follow these rules. So there are 4 rules you have to follow when giving your message. Rule number 1 says that you can only use 4 letters to make 1 word. Hmm.
Okay.
Fine.
Okay. Rule number 2 says that each word must be made from a combination of 3 letters. Rule number 3. The words must differ from each other by the order in which the letters are written. And rule number 4. A particular letter may be used once, more than once, or not at all in any particular word. With these rules, how many different words can you make with the 4 letters?
If they're not real words,
What are
And
the
obviously,
4 letters?
these aren't real
Really,
words, but
like, a lot.
the book told you the answer, didn't it?
Yeah.
What's the answer, guys?
64.
64.
What are the letters?
They should have left that off, and that way, make you guys work it out.
You never know.
You never know. Jackson.
you got to even
I would never.
Now it says here next, these rules describe the language of genes, which is exactly what we're learning about and discovering. In this language, the 4 letters are called, what's the word?
Nucleotides.
Nucleotides, like you see on the screen. So our 4 letters are nucleotides. The words that are made of 3 nucleotides each are called codons. Codons. Now in DNA, we have kind of like a ladder, right? It's twisty. A ladder with rungs on it. A codon would be like a rung. So you have like, here's your ladder, or you step. The step will be like a codon, okay? Now, it says here the words that are made of 3 nucleotides each are called codons. The sentences from those codons are called genes, which we've been learning about. And the sentences or genes can even be translated into another language, the language of protein. Then it goes on and tells us that proteins are involved in nearly anything and everything you do. They're all over your body. They build up your body. They are vital for your very existence. And it tells us that your DNA contains the code for these proteins about your life. So your entire blueprint of who you are and all the proteins that build up and make everything about you are all blueprinted right here in your genes using nucleotides. Whoa. Alright, so let's write down these nucleotides, okay? Now I think these nucleotides would be great names for naming children. Too bad I named my kids Jackson and Eden already. If I would have thought of this sooner, Jackson, you could have a different name. So just remember, nucleotides, we can also call them proteins, but the cool fancy name that Tyler read to us, one of them is adenine. Wouldn't adenine just be a great name for your kid? Hey, adenine, get over here.
You're in trouble.
Or thymine. Thymine, what are you doing? Or cytosine. Cytosine, hush up now. Or how about this? How about guanine? Would you like that name? That's a good guy name. Guanine. Jackson, I should have named you Guanine. No, I wouldn't do that. That's right. But notice they all have "ine" on the end, don't they?
Yeah.
But these are the kind of odd names given to nucleotides or proteins that build up your DNA.
Why?
All right. Yes, Lydia? You can't see the bottom one? All right, it's guanine. It's also on page number 102 They're listed out there on page 102, kind of right in the middle.
Why would they give them these names?
Good question.
Good question.
Yes, Mr. Nelson.
Well, so if there's only 64 possible words they can make, does that mean every single human being's genetics can be described in 64 words? I mean, there's gonna be more than 64 words, but 64 different words.
Right, and just different arrangements of them. That's all it is. And the cool thing is, your genetic code is unlike any other person that's ever lived or that ever will live.
Well, how can that be if there's only 64?
Because they're all organized in different ways and fashions.
And
So,
There's so many.
But
now, if you think of Adam and Eve way back in the garden, they had their genetic code that God gave them. Now that's gotten passed down. A lot of your DNA will look like Adam and Eve's, but then each person has their own set. It's totally unique and totally different. And we have twins in 7th grade. We have 3 pairs of twins in 7th grade too.
3? Oh, yeah.
Even twinsies. Now we have non-identical
True and
twins or
Ellie
fraternal twins. They don't look alike, right? That's Jill. I think that would be you, wouldn't it? You and your brother don't really look alike. So you're not identical twins. So obviously you have a very different genetic code than your brother. Now, on the other hand, if you were identical twins, would your genetic code look 100% like your twin?
No,
No, it would still vary, although you look an awful lot alike. So, that's where,
What about Siamese twins?
ooh, Siamese twins, like conjoined twins?
Yeah.
They would still have their own.
Yeah.
Conjoined? Like,
No, they wouldn't.
conjoined twins, is that what you're talking about?
Would they have?
They have their own.
That's known as a genetic mutation.
Yeah.
Well, yeah.
And we
but
kinda
would
got
the
into that the other
genetic
day, didn't we?
mutation Make them have the same genes?
How are my own genes?
Yeah, a genetic mutation is really when you have something that went,
Wrong.
I don't know if I should call it wrong, because I mean,
Sideways.
God allows it to happen. So I mean,
That's true.
but basically it's usually something that impacts your genes that is usually harmful, usually. So. All right, yes, Tyler.
So Mrs. Bambi last year, the 6th grade teacher, she told us this fun fact that they found that scientists they studied 2 twins, fraternal twins or identical twins,
Mm-hmm.
and they looked at their DNA, and wasn't there something like 2 differences? There were
Yeah.
2 differences out of everything
Oh, wow.
there. There was 2 differences.
Mm-hmm. So isn't that amazing? I mean, God knows each and every one of our DNA blueprint. And ours is totally unlike anyone else. It's 100% our own. And that's why someone in 6th period yesterday was asking about forensics. You know, someone commits a crime and they leave a little bit of their DNA behind. The police can come collect that, they can look at it, and then they think, oh, well maybe, just maybe, it was, I don't know, maybe it was Jackson back then. Maybe the police suspect it was Jackson and Ethan, that they were doing a crime,
Yep.
and so what the police can do
They have to lose their own.
is then find the evidence that the criminal left behind. Maybe they left some hair, maybe some skin cells flaked off, or maybe they cut themselves on some glass breaking in a house. Guys, no. Maybe a little bit of blood was left behind. But the police can collect the evidence, right? Look at these arrangements, find their suspect, and then court order their suspect to, hey, you have to give us some of your genes now. And if the genetic code matches, you know it's that person. Because there's no one else on the planet with that exact same genetic code that you have.
It's kind of creepy to know that they can do
So
that.
guys, don't go out and
Cut yourself
you
a
won't.
glass.
I feel like it's violating some of my rights in the Constitution.
Not if you
Wait, are bringing out the Constitution?
If you were having, what if you had an identical twin,
Mhm.
had 2 differences, and then there was a friendly twin and an evil twin. They accidentally went after
Wait.
the wrong
Oh, no.
one.
Wait, no.
Wait, but they can figure it out because the DNA code is not exactly 100% the
I
same.
know, but what if the twin
Oh.
left behind one of the other twin's hairs to make it think that was the other twin when it was really them.
That'd be a nasty twin.
Wait.
We should make a murder mystery because we would be so great at this.
What? Why would
Why are
this?
you thinking about this?
Abby's the future criminal.
Abby did
Are
it!
you
Abby
thinking
was
about
the
this?
imposter! Imposter! I'm never the imposter, I swear!
Alright.
That's what they all say.
I'm concerned now. So we've learned about nucleotides, right? So switching gears here. We've learned that your DNA is made of nucleotides, but even nucleotides are made of smaller parts and pieces. Can you handle smaller?
No.
Yeah, I did.
All right, even smaller. If we look at the nucleotides, they will be made of things that look like this.
Whoa. What are those?
Now, you see here, these represent atoms. N represents nitrogen, C represents carbon, H represents hydrogen, O represents
Oxygen.
wow. So even your genes are made of these atoms. Atoms build up the nucleotides that build up your genes. Wow, we're getting so incredibly tiny, aren't we? Now we call these atoms that build up your DNA, we call them specifically amino acids. Can you say amino acids?
Amino acids.
We're down to a molecular level.
We are on a molecular level, aren't we?
But what's below the molecular level?
The molecular level.
Okay, atoms. I forgot what it's called, but they are made of something even smaller. Quarks. Yes.
Alright, so amino acids are simply molecules, and you guys know molecules are atoms joined together, right? You guys know that. So we've taken it down really incredibly small, haven't we? So amino acids build up and make your DNA. Now here's the cool thing. There are about 20 amino acids that build up and make your DNA and all the DNA on the planet. Only 20. That's all God needed to make everything that He's made and to make everything so unique that you have your own set of DNA that's totally different than any other human. Your DNA is different from animals, but yet it's still made out of the same parts. It's still made out of amino acids.
Wait, so is there at least one part in human DNA that animal cells don't have?
Basically, it's the same 20 pieces of amino acids, just arranged in different ways and different patterns. So basically, the same amino acids that build up your DNA builds up a bacteria's DNA.
So I could be related to a bacteria. I could be the same as a bacteria.
Now, that's what evolutionary scientists want you to believe. That since we all have the same amino acids, that we're all related to each other.
Haha. But they wrong.
But let's think about that. Just because we have the same amino acids that build up buttercups and butterflies and bacteria and Billy Bob human,
We're so special.
does that mean we're really all related, or does that mean we all have the same creator and designer?
We have the same
Creator and designer.
Same creator and designer using the same ingredients, right?
Yeah.
That makes a lot of sense. It reflects God's awesome design.